Hi, I'm Liam. I'm one of the security consultants here at Pentest People, and today I'm here to show you how, on an engagement I was on a couple of weeks ago, I went from investigating just a simple bit of anti-CSRF to brute forcing an account. We're going to start off by showing you me discovering the application. Obviously, I've had to mock up the app in question because we can't be showing you any client data, but the principle is the same. The code's obviously been obfuscated and changed slightly, but again, principle's the same. And I'll show you how I took that and took the little login portal. We wrote a little script for it. It would have taken too long using Burp Suite, which is one of the primary testing tools that web application testers use. And how I took that and turned it into a working proof of concept that actually successfully got me an account as well. Right then, so let's get started. Here we see me just, here's the application ahead of us. I'll show it you loading in here as well. So we're just, 192.168.64.2. Aggressive CSRF.php, so here's the aggressive anti-CSRF things. Here's what the login portal looks like. This is actually a clone of one that me and a colleague of mine built a little while ago. There's one password popping up there as I try and log in. Yeah, so as you can see, it pops up incorrect when the username and password are not there. I always like to get a quick look at what's behind these login portals. Sometimes there's just janky stuff going on, and in this case I was right. You know, as we can see, we're just going to select one of those form fields just to see the form in there, and there is, looking there in the form, there is a token in there, which we'll have a little look. That script seems to be generating the token, as you can see there. So we're just going to have a little look at what it does. It seems to be some kind of key up function. There's a bit of JavaScript in there, you know, just standard, you know, kind of browser side, you know, browser based CSRF controls. I'm just going to copy that and throw it into a little text editor, just so I can get a bit of a better understanding of exactly what's going on here. Here is in the text editor, you see input on key up function. So, you know, every time there's a key up on an input field, we're going to be getting a new date. We're going to get minutes of that date, and then this token is going to be generated. So it seems to be a token.value is the MD5 of an MD5 hash of the username value, the password value, and the minutes of the date. The split on nothing, the split on kind of zero space there, we'll split it into each individual character. Then we're reversing the whole thing and then joining them back together. You know, you can do similar things in like Python and Ruby just with the dot reverse command, or in Python you could actually just call an array and then do the same thing. It doesn't really matter which language we're going to try and attack it in. It's very doable programmatically. You know, if one person can do it programmatically, the hacker will be able to do it programmatically too. The first thing we're going to start off with here is requiring Faraday. Just have to get rid of that little bit of text there. Sorry about that, Lewis. And then so require Faraday. Just going to save this file here now. Faraday is a gem, a Ruby gem. I picked Ruby to demonstrate this with, just because it's a fast language. I didn't have a lot of time to build this proof of concept. You know, it was a pretty big test. There was a lot of functionality in the app, and so I just didn't want to spend too much time on it. Could have done it in Python. Python would have taken too long, so all I did was I selected Ruby for this, and require Faraday. You see, I just saved it there. CSRF bypass.rb, requiring Faraday there. I'll get in there. I'll probably need digest here. There we go. Require digest MD5 to deal with all our MD5 hashing goodness. We'll have to wrap these in quotes. There we go. I'll realize in about 5 minutes that I've actually put a space in there, and it doesn't let you do that because it doesn't, you know, it's matching the literal string. So you go Faraday with a space is different to just Faraday, and obviously it doesn't recognize that. However, when I was writing my proof of concept, obviously you're trying to go as fast as you can while still trying to stay accurate, and that generally means that in some instances you will just make silly little mistakes like that, or a hacker will make silly little mistakes like that. Again, it doesn't really matter. You pick it up as soon as you run it for the first time, you get it changed. It's all okay. Right then, attack file. Attack file, again, this is just going to be a standard list of username and passwords. I had a inkling that the admin account was there. In the actual application I was attacking, there was some valid username enumeration, and I managed to find out that there was an account called admin. So I was just like, well, if you called admin, probably got a lot of permissions in there, and the password policy wasn't amazing. So I'd just said, right, we're going to go after the admin account, and probably we're going to be able to get in using a very cut down password list, or at least, one of the top 1,000 ones that you occasionally see floating around. Again, reading all the passwords out. So that's this is just, reading a .map. I love that little .map chomp. I think I'm going to be doing that, and chomp, yeah. Very nice, very nice. So that's just going to read it out line by line, strip off any white space, standard stuff. So we just have nice little password list that we can iterate over and start firing requests off using Faraday. Attack file.close, always close your files. Don't need the unless there. Always close your files afterwards. It just causes a massive pain otherwise. Some people like to just leave them open. If you're on a remote machine and you want to start causing issues for people, I guess you can leave it open there. But if you're on that point, you probably want to be trying to be as quiet as possible anyway, and generating errors is generally not what we want to do. So here we go. I think we're going to have to throw a little loop around this. Yeah, we are. Cool. So I'm just going to throw a little loop around this. I'm going to speed the rest of this bit up. Me talking over coding is probably not really what the point of this is. It's more about the mentality behind it. So I'm just going to skip through, and we'll pick back up when I've got a little bit more of this written. Okay, and we're back. Right then. This part is kind of, part of the reverse engineering side of things. It's part of, figuring out exactly how the client-side control is working, and then just basically reformatting it. Very fortunately for us, JavaScript's really easy to understand. If it's something that kind of testers aren't aware of, definitely something you should be learning. But all the testers that that we've got here know enough JavaScript to reverse engineer things like that. Basic client-side controls, just things that are going on. As you can see here, just exactly the same as was on the page previously. We have MD5ing and MD5. Then we've got time.new.min.2s. So that's just taking the minutes of the time and then turning it into a string, because otherwise it treats it as an integer. And unfortunately, trying to add alphanumerical characters and integers in programming languages, it doesn't like it. It starts shouting at you. And we want to try and avoid that if at all possible. As you can see here, we have the token there has just been successfully reverse engineered. That it'll now correctly generate the password. The body is just some nice basic JSON. Sorry, don't know whether the word escaped me then. And again, we'll fast forward to the rest of this. I just wanted to speak through, the thought process behind the token reverse engineering. And just hopping back in here, just to explain that the user agent part here is quite an interesting one. Generally, what we dislike is using user agents. I just broke the whole thing there. I dislike using user agents that look dodgy. So for example, Faraday hasn't used its own user agent. If you're using Python's requests module, it has its own user agent. I don't like any of those. I will like manually specifying mine. It just means that if we are attempting to be malicious here, and if somebody is looking at the logs and you see something from Python requests, immediately looks dodgy. You see something with a Faraday user agent, immediately looks dodgy. It's about disguising your actions as well. And this is a big part of it. An extra line of code means that you look like you're using Edge on Windows 10. And if you were going after, say, Microsoft's Azure tenancy, the way they identify what operating system you're using is by this user agent header. There's no way of telling, at least according to them, that you're on anything else if that user agent is specified to something a different operating system user agent would be. So I like to use Edge on Windows 10, which is great. And we're back. So this is me showing off the, okay, so we're not actually going to come back here. Sorry about that, jumping the gun. This bit needs to be cut because we can't include my folders. And we're back. Right then. So we're just generating a pass list here. As this is a proof of concept, I'm just going to write out 4 or 5. In the actual engagement, I think I had a list of about 1,000 that I just started running through. Again, really depends. You know, when I'm attacking things, sometimes I'll go after credential stuffing. However, the admin portal seemed to only be internal use, and you know there were some other security controls potentially around that as well. So I decided I'm just going to go after the admin. I'm not going to bother with the credential stuffing. We have an absolutely amazing credential stuffing, platform that we use. It's up on GitHub. It's called Athena. I'd really recommend that. However, for the time being, we're just going to stick to the simple little bit of brute forcing. Nothing too fancy here. Just a nice little brute force. So yeah, as you can see, passlist.txt, going to get that saved off now, and then just throw a load of passwords in there. Probably going to use things, just use things like password1, password, admin. If I was, if this weren't a proof of concept and I was going for a slightly longer list, I might start including things like the company name. So, company X 2020, lockdown 2020 has been a big one recently. So has winter 2021. The season's always a good one, especially because generally companies are starting to enforce password changes of 3 months. So starting to increase the password length time. Unfortunately, 3 months roughly lines up with whatever season it's going to be. And you're like, well, okay, let's just call it spring 2021. Nice and easy. People can remember it. As you can see here, though, I'm doing password, admin, password1, and then password1 with a capital P. 10 points to whoever can guess which password it's going to be, given this is a proof of concept. Yeah, so we're just going to get that all saved nicely now, and then we'll start to run the commands. And we're back. As you can see, what's going on here is, there was one or two little errors in there, nothing major. Then the CSRF bypass thing, one or two little things. I'm going to go fix those. And what I always like to do is I think it's really important to try and make your proof of concepts as small as possible. I at least like doing this when I'm on engagements. Sometimes you'll find, especially with more injection-based attacks, so that would be your SQL injection, your cross-site scripting, whether it's persistent, DOM-based access, whatever. You find that sometimes there are actually length limits, not enforced client side, because we can bypass those. So if you ever set an input field, say, and it's enforced in browser that it's got to be only 10 characters long, we can bypass that just by editing the DOM. Really nice and simple. However, sometimes the database will have length limits enforced, so it can't be over 25 characters long. And if your proof of concept's 26 characters long, because you've never learned how to condense these things down, obviously you're scuppered. It's going to hit the database. You might get 500 internal server error, but that's probably going to be about it. Maybe a little bit of info disclosure, but more importantly, you don't have that nice, slick, clean proof of concept that we love showing clients, and really helps to demonstrate to both non-technical and technical people why these things are so important. In the instance of cross-site scripting, how many people who've ever seen a pen test report have seen alert 1 in it, or just a little box with a 1 in it? What does that mean? Well, it's quite hard to explain that. So that's why, being able to write your proof of concept, get it nice and short so that you can always get that in there, it is so vitally important. I think I'm just about to show you here when I've condensed it all down. Just zoomed and did that off camera, but yeah, we get it all nice and short, and I'll show you that in about 3 seconds here. And here we are. So here's the condensed version down. Now, obviously, we could replace the start of it with some file reading. I've just got a little array that I'm going to iterate over. Yeah, again, copy file path. Let's just get this in there. No files required to be things. So Ruby, bang that in there, hit enter. Obviously, that's not going to work because I've got spaces in my file paths. Very bad. Practice that. Don't be following my example there. So here we go, Ruby. There we go. Tick us all back there. Get that nice little backslash in there. Bang, hit enter, and password is password1. cracking. So we've our shell, oh, sorry, not our shell, our script is now working, and it's only 2 lines long. So, you know, really nice and condensed down. If there were any length limits, that would be your best shot at bypassing those as well. As you can see, the token there is regenerating, but password 1 was correct. Nice one.
I hope you enjoyed that slightly more technical look at kind of cross-site request forgery and brute force attacks, and how we take what we see out there in the wild and turn it into real exploit code that gets used on our customer engagements. Not the normal content we put out there, but we thought it might be quite nice for you guys to see what goes on under the hoodie, or rather in the office, when we're performing penetration tests. I've been Liam, and this has been a pleasure. See you in the next one.